magic thing. I believe you can do it so fast. So again, write both constraint and solve VABs and CC. We just wrote down everything that we need. Compute the current and power in each voltage source. This is going to be your assignment. Try to do that. Try to find all of the current that moves this way, move that way, and also all of the currents that we had in our mind in order to find all of the current. Then by using just V times I or whatever equation, you can just simply find all of the powers that you need. So outpacing mesh on its home turf. So at this point, I do have another question. That I do have a 12 volt, I do have 4, I do have another 4, and I do have what? And I do have it as 2 amps. So the question again is simple. Try to find the voltage at VA and VB. As we all know, again, we are dealing with mesh analysis, we're doing the node analysis. We do have 2 nodes over here. So everything should be simple. It shouldn't be that hard. And let's just move it so fast how we can answer it. Again, for the VA, at this point, I do have what? As you guys just know, I do have a problem. And this problem is that I do have a voltage source in one of the branches. So it means that I have to use the supernode. But wait, I know one thing for a fact, that VA itself is going to be 12 volts, right? Because VA is in parallel with 12 volt and a source, and the ground. So it means that the VA is just simply 12 volt. I can find whatever I need by only using the KCL on node B. So what the KCL on node B says that all of the current that this guy has are going to repel from itself are going to be 0. So what do I have as current? For example, the first one, the second one, and the third one. So the first current is just about the 2 amps, since the direction is going to be opposite, say that -2 plus VB divided by 4 plus VB subtracted by 12 divided by 4 equals to 0, right? I'm going to multiply everything by 4 because I would like to get rid of fraction. If I do that, I do have -8 plus VB subtracted by 12 equals to 0. If you rearrange this one, your 2VB equals to 20 and your VB equals to 10 itself. As simple as that. VA was 20, 12, and VB is going to be 10. So simple. So we solved it. Compute the current in each resistor. It's not that hard because at this point that VA is going to be 12. So the current moves this way, and I do have it as 12 divided by 4, which is 3 amp. About this one, say the only thing that I have is the VB, which is 10 divided by 4 is going to be 2.5. So obviously, if I do have 3 amp and 2.5 at this point, means that the current over here, it was 2 amp that moves the direction. Let me just fix that one for you. So I do have it as 2 amp that moves this way, and I do have 2.5. So obviously the direction of current should be this way. Let me use another color. Should be this way, and this is 0.5 amp. As simple as that. And obviously the current that we do have over here, and we found every resistor. So that's everything. And confirm that KCL at node B numerically with the computed currents. So we just did it, right? We just assume that everything is okay. We do have 2 amp, we do have 2.5, and we just found the 0.5. So everything is going to be settled and right. So to see that not all of the questions are going to be that complicated. Imagine that you would like to solve it based on the KVL. You still have to you do the KVL, find all of the voltages. Well, right now, but using the simple and basic knowledge related to the parallel and series circuit, you found everything that you need. So another thing that we do have is about the dependent current sources. So these guys are not going to cause us that much of a problem, but it still is worth it to see what's going on. So at this point, I do have 20, I do have 10, I do have 5, I do have 1 amp that gets inside one of my nodes VB, and I do have one source, which is a dependent current source. As you see, it's just 0.2 times the VB that gets out of the node A. So at this point, I would like to find it. Let's do it. What does it say? I do have, again, 2 nodes at this point and this point. So let's write down the case for each of them, and after that, try to find them. KCL at part A says that, again, we consider all of the currents that are repealing for each branch. So KCL at part A says that the current, because of the dependent source, is going to be VB divided by 5, which is obviously 0.2 times VB, plus VA divided by 10, plus VA subtracted by VB divided by 20. The KCL at point B says VB divided by 5 plus 1 amp that moves another direction, or 1 plus VB subtracted by VA divided by 20 equals to 0. So the only thing we have to do is just multiply both parts, KCL A and B, by 20 to get rid of all of the fractions. So if I multiply the KCL part, some kind of the KCL number A by 20, what do I have? I do have 4VB and plus 2VB plus VA subtracted by VB equals to 0. So it means that at this point, I do have 3VB. At this point, I do have There's 1 VA, there's, oh, sorry, my bad. At this point, you should have 2 VA. Makes sense. So I do have 3 VAs plus 3 VB equals to 0. So it means that VA is going to be negative of VB. I do have this thing. Then we have to multiply both sides by 20 on the KCL number B. So I do have 4 VB subtracted by 20 plus VB subtracted by VA equals to 0. So if you rearrange that, what you got? You have 5 VB subtracted by V equals to 20. One thing that we know, that VA is equals to negative VB. So I can write it down as negative VB. And if you rearrange this one, 6 VB would be 20. Based on that, your VB would be equals to 20 divided by 6, which is 10 divided by 3. And VA would be equals to negative 10 divided by 3. As simple as that. Again, try to check it in both KCLs and you see the right answer. To compute the power independent source, still is going to be okay because we do have the current source, right? So I do have my VB. So the only thing I have to do, 0.2 by VB. I do have the voltage. Then I do have the current that goes this way. So I'm sorry, I do have a voltage based on the current that moves through the 1 towards the 10. How I can find it? I can just divide VA by 10 and I can find the current itself, and you can find anything power related to dependent source. So let's look at another challenge, the dependent voltage source constraint. So at this point, we would like to see that what would happen if I do have the dependent voltage source instead of just a normal source in one of the branches. So again, we are going to do everything as the way it was, just a normal thing. We don't have to worry about any part. So let's just do it. So at this point, again, we do have two parts, node A and node B. Obviously, since we do have the voltage source, we cannot write down some kind of what current goes back because we don't have any information related to the resistance itself. It means that again we have to use the supernode. So based on the supernode, I do have I1, I2, and I3. I have to write down the KCL and everything should be settled. So based on that, again, the KCL of the supernode would be I1 plus I2 plus I3 equals to 0. Let's write down I1 equals VA divided by 6. VA subtracted by 0 divided by 6. I2 equals to VB subtracted by 0 divided by 3. And I'm sorry, I2. And I3 would be what? Would be negative 2 amp. So the only thing we have to do right now is just write it down. But wait, we still need another equation because right now if I put everything over here, it would be one equation, two unknowns. And what is another equation which says that V subtracted by VB equals 2VA. So from this point of view, we can say that V equals to negative VB. This is not information that I know. So the only thing I have to do is just rearrange everything over here, and then I can do whatever I like. Simple as that. So if I rearrange the first one, what do I have? I have VA divided by 6 plus VB divided by 3 subtract by 2 equals to 0. So I have to multiply both sides by 6. 0 is just 0. But if I just do the 6 by each of those terms inside the left side of equation, I do have VA plus 2VB subtracted by 12 equals to 0. Or VA plus 2VB equals to 12 itself. So right now I know VA is equals to negative VB, so I can write it down as negative VB plus 2VB equals to what? Equals to VB, and I do have it as 12 volts, and also VA equals to negative 12 volts. As simple as that. So what are the part of question? The question just mentioned that consider this one as one of your equations. We did use that and determine the current through the dependent voltage source and its power. So related to the current, we can do that. V is going to be what? VA was negative 12. So it means that right now I can write I1 equals to negative 12 divided by 6, which is negative 2 amp. Since I do have a negative 2 amp, it means that the real direction of this was 2 amp. So this 2 amps go through this point. I do have it as this, so it means that the current goes through the dependent source would be 2 amp itself, and you can find all of the powers related to dependent source and all of the sources and all of the resistance if you like. So this question would be a little bit interesting. The floating current source. At this point you see that I do have 8 ohm, I do have 4 ohm, I do have 1 amp, and I do have another resistor on the top, and then the question simply asks to find the currents, find the voltages. You have two options. The very first option is about the source conversion. If you guys remember, we can convert a current source with the parallel with a resistor to a voltage source, again in the series of that specific resistor. And that could be very simple, we can find that. Another option that we do have, we can just think about it logically. The current that moves through here is going to be the same as current that goes through here. It means that somehow I can consider the whole thing as the supernode and then say that whatever current that gets inside this supernode is going to be the same as whatever current that goes outside of this node. So this is one part of the job. Another thing that I have to know is that this current plus this current is going to be this current. How I can find this current? It's simple. VA subtracted by VB divided by 60. By using these two, I can find whatever current that I need. So let's see what would happen. At this point, let's just imagine that we don't care about the case here related to the VB and VA. We are just going to use the normal way that we know. And we just consider one direction. And we assume that I3 and I1 and I2, all of them are in the same direction. Obviously, you see that a problem would happen. Not a problem, actually, but your assumption is not going to be right. And the formula itself is going to fix it. So don't worry. So I3 equals to VB subtracted by 0 divided by 4. I1, on the other hand, if I consider this guy as positive and negative, would the voltage of positive is 0 and the voltage of negative would be VA. So you have to be very careful about using this formula. So the fact that VB divided by 4 equals to negative VA divided by 8, if you do the cross multiplication, means that your VA is going to be negative 2 VB. This is one. Another thing that means that actually I1 equals to I2 plus 1. So what was I1? We found it as negative VA over 8. What about I2? I2 is going to be equal to VA subtracted by VB divided by 16. So if I do that one, what do I have? I do have negative VA divided by 8 equals to VA subtracted by VB divided by 16 plus 1. Then we have to multiply both sides by 16. It's a common denominator or least common denominator. So it would be negative equals to VA subtracted by VB plus 16. So I can do the rearrangement. And at this point, if I do that, it would be VB subtracted by 3V equals to 16. It is the second equation. So I know for a fact that VA is equals to negative 2VB. What can I do? Instead of just VA, I can write it down as negative 2VB. If I do that, negative 2 times negative 3 would be positive 6. VB plus 6VB equals to 16, 7VB equals to 16, VB equals to 16 divided by 7, which would be 2.3. So I found the VB. VA is going to be negative 2 times VB, or V is going to be negative 2 multiplied by 2.3, which is negative 4.6 volt. I do have everything that I need. Then obviously the question asks for the current that goes through the 16 ohm. So obviously since but VA was negative 4.6, VB was positive, well, positive 2.3, obviously the current should go this way. It doesn't matter that what direction we use, but finally the question itself is going to some kind of fix the issue for ourselves. And then you can find the power inside each of them, and you can somehow prove that whatever power this guy is producing is the same as this power guy is consuming, and this guy and this guy. Simple as that. Then we do have the discipline of matrix formulation. So what would happen if I do have maybe 3 nodes? So at this point, I have to be a little bit careful. Why? Because at this condition, I'm going to face 3 equation, 3 unknowns. It's not just like before that we are going to have 2 equations, 2 unknowns, at 1.1 equation, 1 unknown. It's going to be a little bit complicated. And at this point, you see that we do have another node with the name of D, which actually unnecessary. We can ignore that because whatever current that goes inside of this one is the same as this one. So the VD is not going to give us that much of information. We can just get it up. So far, 3 important nodes would be A, B, and C. Let's write down equations related to them and find voltages. For the KCL number A, or the KCL A, is what I do have again. I'm going to assume all of the currents are going to repealed. So it's going to be the first one is going to be related to 2 amp. Since the current that I have over here is going to be in opposite direction, I'm going to consider negative 2 plus VA divided by 4 plus VA subtracted by VB divided by 2 equals to 0. This is the first one. The KCL number B says that whatever current that is repelling, VB subtracted by V divided by 2 plus VB divided by 4 plus VB subtracted by VC divided by 2 equals to 0. KCL number C, KCL number C would say that VC subtracted by VB by 2 plus VC divided by 4 plus VC divided by what? Divided by 6 equals to 0. We just somehow got rid of it and assume that all of the currents is related to 4 and 2, which obviously is going to be 4 plus 2, just 6. So that's everything we had. Let's get rid of all of those fractions. It means that if I would like to do that way, I have to multiply both sides by 4. Same. Both sides by what? But 12. Remember that because you have 6 and 4. So let's have the first one. The KCL number A would be changed it to something. Multiplied by 4 would be negative 8 plus 2VA subtracted by 2VB equals to 0. This is one thing. KCL would be 2VB subtracted by 2VA plus VB plus 2VB subtracted by 2VC equals to 0. Then the KCL number C would be what? The KCL number C would be multiplied by 12. So it would be 6VC subtracted by 6VB plus 3VC plus 2VC equals to 0. So let's again simplify them. I do have 3VA subtracted by 2VB equals to 8. For the second one, I do have VB, I do have negative 2VA. I'm going to just put them in an order because I need that. Plus 4VB and what else? Negative 2VC equals to 0. For the final one, I do have no VA, just VB, negative 6VB, and plus 11VC equals to 0. So you do have 3 equations, 3 unknowns. Doesn't matter what way you use. You use the matrices, you use the elimination method, you use the substitution method. For instance, at this point, you can find VB based on VC, then put it over here to find another equation, and then use this equation to find one of the variables and move forward. If you do all of that, your final answer should be something like this. VB is 4.14, VA is 8.1, and VC is 2.26. Based on that and using this one, you can, and based on that and using this way, you can find all of those variables and those voltages that you need. As simple as that. The only thing you have to be careful is that you have 3 equations, 3 unknowns. So the strategic choice of ground, because at some point you don't have the ground by yourself and you have to find a specific point for that. At this condition, I'm just telling you that first of all, ground is going to be a point that has the most of connection to it. This kind of positions, when you have the same amount of connection to each node, you have to decide that which place should be the place of ground. So if I consider this point as a ground, let's see what would happen. If I consider this point as a ground, again, I do have this guy. It means that, let me just use another color. I as my node, I obviously, and I do have this guy. So what I need, sorry, I need to write down based on 3 nodes, obviously. I have to use what? Based on the 3 nodes, I have to use the KCL for this one. And I know I cannot do that, so I have to use the supernode. Then I have to use the KCL for this one. It would be a little bit mess. But what would happen instead of that, instead of just considering this part as my ground, I consider this section as ground. So you see, at this point, the amount of current that moved this way is going to be 1 amp. It means that I don't need to worry about C. So the only thing that I need to worry is about the B and about the A itself. In the meantime, I know VD is going to be 0. Don't have any problem. Then if I'm going to use the supernode condition, I still don't have any problem with that. Why? Because already I know what is A. V is just 10 volts. So the only thing that I'm worried is about the VB. That's it. So simple. We don't need to know the KCL. We don't need to use the KCL. Obviously, we don't need to know the KCL. So that would be very, very easier. So let's consider that. At this point, I'm going to use the D. I'm not going to use any supernode because obviously VA is going to be 10 volts. Then what do I need? I need for a fact that VB subtracted by VA divided by 5 should be 1. VB subtracted by VA divided by 5 should be 1. So it means that VB subtracted by VA is 5, right? What was VA was 10. VB subtracted by 10 is 5. And VB is 15. VB is 15. VS is 10. VD is obviously is 0. And the one thing that I need to know is about the VC itself, right? So this one is a little bit challenging right now because it could be a little bit problematic at this point. So when VB, even this guy is 10 volts and this guy is somehow 15 volts, I know for a fact that the current goes this way. Is that right? So when the current goes this way, I already have the current that goes from this way. When the current goes from one point to another point, we consider this guy as positive and negative. It means that I do have a voltage drop over this 5 ohm. Whatever voltage that I had over here, obviously 0, should be subtracted by whatever voltage that this guy is going to consume. So VC is going to be V0 or VG or whatever subtracted by 5 times. It's going to 0 subtracted by 5 times 1 is going to be what? Negative 5 volts. As simple as that, right? We do have every number, we do have everything. We can do anything that we need. So what would happen if we do have solve the question backward? It means that instead of just normally find VA and VB, the question already gave us something that VB is something and you have to find the RX. So let's see what would happen on that side. Still, I'm going to use my KCL and I have to find the RX. Let's see it's going to be this number or not. What do I have to write? I have to write again 2 nodes. I have to write the 2 KCLs. Again, the currents are repealing. I have to consider this fact. And VB is already 4 volts, so that is okay. The good thing right now is that we can think a little bit. Since VB is already 4 volts, it means that I already know how much current is going to pass through this way, right? So this current, which obviously is going to be the same as this current, is 4, because it's VB, divided by 3. Which is going to be around 1.33 amp. Simple, right? So the only thing that I need to care is about what is happening as a VA. Let's see what would happen. So based on that, I know something. That V divided by Rx subtracted by 3 plus VA subtracted by VB, which is 4 volt, divided by 6 equals to what? 0. I also know that the current, obviously I don't need that, because as we know, the current on that point is going to be 1.33. But it's not enough. As you can see over here, I do have one equation, 2 unknowns. So what is another? Another unknown is that VA subtracted by VB, or 4, divided by 6 is 1.33. So I can say that V subtracted by 4 divided by 6 is 1.33. Then I can find by VA. It is so simple. It's just about rearrangement. It is so simple. You can find a number. When I found VA, I can put it just over here. And after that, I can find RX. So if you do that, your RX should be 7.05. Based on that, you can find the power, you can find the current. So at this point, we do have our final challenge, which is related to everything that we learned so far. And you guys can completely do that because it's completely related to the supernode, the dependent source, and it's going to be a little bit challenging, but I'm going to ask you guys to do it by yourself. And again, just answer me on the comment down below. And if you have again any question, I can solve it for you. So far we consider a new way of teaching at this channel that we're just using examples. Because the nodal analysis is going to be a very important analysis when you compare it to the mesh, the Thevenin and Norton, and superposition. You're going to use that a lot. That's why I thought it would be better to just learn it through examples. By rewatching this video, by making sure that you're doing everything right, you can have a very high confidence related to this matter that you can solve any question if you have it in your exam, or if you have maybe at your work, or you have some kind of the simulation system that you're using without any issue. Again, if you have any question, if you have any comment, I would be more than happy if you just try to put comment down below. If you like my video, I would be more than happy if you could just share it and like it. My name is Mahmoud Kiasari. Thanks for being here with me so far. Have yourself a great day, night, whatever. See you around.